Welcome to Wildcat Science with Mrs. Hauko. This is Physical Science, Chapter 1 Forces, and we are on the lab 1.2 weight and the spring scale. Please go to Classroom and open up your Google Doc 1.2 weight and the spring scale, and please follow along while we're doing the lab. It's a little bit different than normal. This is going to be kitchen table science. So, pause the video until you have that up. So 1.2 weight in the spring scale, the purpose is to demonstrate the need to use a standard unit for weight, which is the Newton. Okay, procedure Part A, Round 1. Obtain a spring scale and a jug. So here we have a spring scale and a jug. Attach a strip of masking tape over the set of permanent marks on the spring scale and hang the empty jug from the spring scale. And never pull down on this so that the plunger goes past the last mark. So let's do that. So now I have masking tape over the marks, and I'm going to hang the empty jug from the spring scale. Now it says, carefully, let's get our words in the way. Get a picture out of the way of the words. Carefully mark the position of the force indicator on the masking tape with a line and 0 while the jug is on there. So here is my force indicator, and I'm going to mark that carefully with a line and label that 0. There you go. And then I'm going to use a graduated cylinder to carefully measure out 100 milliliters for round 1. I don't have graduated cylinders here, but I do have a measuring cup which is marked with 100 milliliters. You're not quite, kind of got it tipped so it looks like it's more than 100, but it is exactly 100 milliliters. And then I'm going to pour this water into the jug and then going to mark with a line where the force indicator is now. So you might be able to see there's a plunger right there, and I'm going to mark a line there and label it 1. So now you can see I've labeled 0 and then 1 special weight unit. Now we have the next step is to pour this water into the jug like we did and repeat steps 5 through 6 until you get to mark 5. So we've done 0, 1, and now we'll do 2. And then I will hang this on the spring scale, and I will mark the level of the force indicator and label it 2. So you can see, there we go. Now we're ready for round 3. I've already put the water in there, and I will mark the level of the force indicator. And there is 3, 0, 1, 2, and 3. For 4, I'll put the water in. Hook it up to the spring scale. Mark the level of the force indicator, and that is 4. We need to hire a new camera worker. And then there is 4. Finally, number 5. Okay, as you can see, there is that much water. And maybe I'll mark that in there so we can compare it to round 2. Okay. And looking at your spring scale, you can see we have, it's kind of got light shining in on it, but 0, 1, 2, 3, 4, and 5. Now, what is the next step? Q1. What are the distances between consecutive marks on your tape and round to the nearest tenth of a centimeter? So what we would do is we would get it so that we go from 0 to 1, and we would measure that. So I will do that. So the distance is 0.6 centimeters. And so you would put that answer right here and make sure to use units, which are centimeters. 0.6 centimeters. And then Q2, does the spring scale stretch by equal distances for equal increases in weight? So we can take a look at it here. And you can see that it is not exactly the same, but it is quite close. And we would expect that because we used the same amount of water on for each addition of weight. So you'll want to use a race answer here. Starting out, the spring scale stretched by equal distances for equal increases in weight because, and then explain your answer, and you'll type it right there. Then we're going to move on to number 8. And again, remember, you can pause the video to give yourself time to answer the questions. Make a smaller mark exactly halfway between each of the marks you have labeled on your tape. So what I'm going to do is I'm going to mark in between each of those. So if you can see, I marked in between each of those in blue. And Q3, what is the value of this division rounded to the nearest tenth of a centimeter? So the value of this division is 0.3 centimeters, and you would write that right there. And then we are ready to move on to round 2. And so we're going to repeat a lot of the steps. So it says obtain a spring scale. So I have a different spring scale and a jug, and attach a strip of masking tape over the set of permanent marks on the spring scale, which I've already done, and hang the jug from the spring scale and carefully mark the position of the force indicator on the masking tape with a line and 0, which you can see that I have already done. And then it says to use a graduated cylinder to carefully measure out 200 milliliters. So now the amount of water on each addition will be different. And then pour this water into the jug and carefully mark the position of the force indicator with a line and label this 1. And then repeat steps, well, not 5 and 6, but 13 and 14 until you get to mark 5. See that now I have 200 milliliters marked out, and I'm going to pour that in my jug. And I'm going to use my spring scale. I'm going to hang it from the spring scale, and I'm going to make a mark at the top of the force indicator and label that 1. So you can see that. And then I'm going to repeat that to do step 2. Water for the second mark. I poured in 200 milliliters I hang my jug from the spring scale. I mark the top of the force indicator and label it 2. And then we're going to repeat that for line 3. See, I repeated that for line 3. I added 200 milliliters of water and marked where the spring scale was when I had it on the jug. And now let's repeat it for line 4. So I'm going to add 200 milliliters of water. Going to attach the jug to the spring scale. I'm going to mark the top of the force indicator with a line and label it 4. And as you can see, there it is. And now we have one more to do. Our final addition, 500 ml of 200 milliliters of water 5 times. I'm going to mark the force indicator, label it with a 5, and there we go. There is our scale. So let's see what is next. Well, that's not Q1. I'll change that on yours. What are the distances between consecutive marks on your tape and round to the nearest tenth of a centimeter? So I'm going to get my ruler and I'm going to measure the distance. Distance is 1.0 centimeters. And then the next question, does the spring scale stretch by equal distances for equal increases in weight? Why or why not? So if we look here, it is pretty equal. And so each time we added 200 milliliters of water to our jug, so we would expect that there would be an equal weight and that our spring scale would stretch by an equal distance. So remember to use a race strategy. The spring scale stretches by equal distances for equal increases in weight because, and then explain your answer. The next step is to make a smaller mark exactly halfway between each of the marks you have labeled on the page. So I will do that. See, I have made marks halfway in between, and then I measured the distance in centimeters, and it was 0.5 centimeters. So please write that down and make sure to use units. Now we're ready for part B, where we're going to obtain object 1. Before we do, let's look at the amount of water in the jug compared to last time. So I said I would mark it, and as you can see, this was the total amount of water in round 1, and then there's the total amount of water in round 2, and obviously it is more. So as you can see, I have obtained object 1, and using round 1 spring scale, measure and record its weight, reading your scale to the nearest half unit. So here is round 1 spring scale, and then I'm going to hang it from that, and I'm going to look at the force indicator to the nearest half unit, which is 3. And then I'm going to put my data in the data table 1, and round 1 object, my weight is 3, and my unit is the special weight unit of water that we used. Number 19, using round 2 spring scale, measure and record its weight, recording your scale to the nearest half unit. So I've got my round 2 spring scale, and I'm going to measure, and you can see it's quite a bit less, and that is 1.5. So record data in data table 1